All right, my fabulous chemistry students, ionization energy, trend number 3. Try and get through this before the big bad bell rings. We need to understand how ionization energy is going to change. First of all, what it is and why is it going to change. And of course, I have different numbers of electrons, so my ionization energies, of course, are going to be different. The ionization energy is the amount of energy needed to remove an electron. So stingy with electrons like Scrooge, again. If I have element X plus energy, I'm going to get an X ion plus an electron. Notice this electron was removed. Took it off of that and made an ion. So ionization energy, basically how much energy to make an ion, to remove an electron, okay? As I go across the period, the ionization energy is going to increase. Not sure why that didn't show up, but I will write it. Increase. Increased nuclear charge. So shielding does not increase, okay? But I have more I have more pluses in the middle as I go across, holding on to those electrons, so it's harder to get that electron off. Also, think about it this way. If I have Na with 1, and I have, in the same breath, Cl with 7 valence electrons, who wants to lose an electron more? Does chlorine want to go to 6 electrons, or does sodium want to get rid of this and have its octet? So it's going to be a lot easier for me to get this electron from sodium. It's going to be a lot harder for me to get this electron from chlorine. So the ionization energy on chlorine is going to be higher. Okay, here's a little chart talking about that. And as you see, helium, neon, argon, krypton, these are all the noble gases. So it goes up as I go across. Going down a group, the ionization energy is going to decrease, and that is going to be because of the shielding. So let's look at this first one. You see that this electron is very close to the proton, and in this case I have an electron way out here, but I have two electrons shielding my 3 in the middle. So it's actually easier to get rid of this. And then in this case, sodium, I have one way out here, and look at all of these electrons in the middle shielding. This electron out here does not feel the plus in here very well, and it's even easier to get rid of that electron, for me to take it, if you will. I like the analogy of running with a football and holding it out in the palm of my hand. And in that case, sodium's holding it out farther, so I don't have to put as much energy to get it. But remember, Tiki Barber used to hold that ball high and tight, and it used to take a lot of energy to get the ball from him. So we know a little bit about ionization energy, the amount of energy needed to create an ion, hence take an electron. Now we know what happens as I go up, and as I go up and down, and as across. We are done. You guys got homework to do. Nice short video, 3 minutes, baby. No bell. See you tomorrow.